Okay, so on day 2, um, these are the notes that you should be looking at. And there's a box that says remember. Well, obviously you don't remember it because I didn't give this to you yesterday. So yesterday, remember we talked about conditional probability and we targeted the words if with conditional probability and given. So you're not just looking for the probability of something, you're looking for the probability of something kind of like depending on something else or given something else. I gave the examples of like your parents say you can go out tonight if you clean your room or things like that. Okay. So yesterday we didn't need a formula because we had sample spaces that um, we had the entire sample space, such as dice, such as cards, things like that. Or like on the last example on the back page of the notes, you were given all of the information that you needed in order to solve the problem. So today we're going to use the formula. So this is one more formula that you want to add to your repertoire in addition to the 2 we know already. So the probability, remember that's written, read as A given B equals the probability of A and B divided by the probability of B. Now remember, B is your new sample space. That's what the given is. It takes down your sample space from what the original was. And notice that that will always be your denominator. Okay, so this new sample space will always be your denominator. So A and B over B. So if we look at the first example, again, these are pulled from your student workbook, but we added to it and just wanted to give you more space, which is why they're on a sheet of paper. It says, last year at all technical high school, 20% of students received an academic award. That same year, 16% of students received an academic award and a service award. So you're going to start seeing the words and or again. What is the probability that a student who receives an academic award also receives a service award? So you guys, a couple things. I see a 20%, so I want to focus in on that. I see a 16%, so that's something I want to pay attention to as well. I see an and, so that's one of our key words from the very beginning of the chapter. And yesterday we talked about if and given. Now we also have this word also. Okay, so also will also tip you off. Gosh, sorry, now I'm using it all the time. That you're dealing with conditional probability. Not as much. These two are going to be your main conditional probability kind of like triggers, but also could be a possibility. So what I'm going to do is I'm just going to start by saying, okay, what does a 20% mean? It says 20% of students received an academic award. So the probability of an academic award is 20%, which I'm just going to write as a decimal, so 0.20. And then the 16%, it says that same year, 16% of students received an academic award and a service award. So the probability of an academic award and a service award is 16%, so 0.16. Okay. Now the question at hand is, what is the probability that a student who receives an academic award also receives a service award? So it says, what's the probability that a student who receives an academic award also receives a service award? We want to know the probability of a service award if, or given, or also, we know that the student received an academic award. So there's your conditional probability, and that's what we're looking for. So if you use this formula above, notice your sample space is going to be the AA because that's in your condition. So we're looking for what's the probability that a student who receives an academic award. Okay, this is just describing the type of student. That's how I came to my conditional here. Also receives a service award. So technically the question is saying what's the probability that a student receives a service award. This whole part is just describing the type of student we're looking for. So you're going to set this up as the probability of a service award, knowing they got or given or something like that, if they got a service award, is the probability, academic award, of service award and academic award divided by the probability of an academic award. So then we're just going to substitute in what we know. This is what we're looking for. Probability of a service award and an academic award is 16%. and an academic award alone is 20%. So if you go through and do 0.16 divided by 0.2, you find your unknown to be 0.8 or 80%. So that means there's an 80% chance that if you have a student in front of you that got an academic award, there's an 80% chance that they also had a service award. Okay. So the next question says, a total of 20%, so again, as soon as I see numbers, I'm going to circle them, of a fire department's firefighters are in the special units division. A total of 8% of the department's firefighters are in the special units division and have a college degree, so one of our key words there. What is the probability that a firefighter in the special units division has a college degree? Okay, so again, it's just like the question above. What's the probability that a firefighter in the special units division, that's describing the firefighter. So you can read it as, what is the probability that a firefighter has a college degree, knowing that they're in the special units division? Okay, that's the no part from yesterday. So the 20% is the special units division. So the probability of the special units division, oops, let's try that again. Special units division is 20%. And 8% describes the firefighters that are in the special units division and have a college degree. So the probability of the special units division and a college degree is 8%. Okay, make sure when you're converting those, you do that correctly. And now it's asking, what's the probability that a firefighter has a college degree? So I'm rewording it so it makes sense. What's the probability that a firefighter has a college degree, knowing that they're in the special units division? So the probability of a college degree, knowing they're in the special units division. Okay, that's our unknown. So following our formula, the probability of our conditional, that's our unknown, equals the probability of both, so the special units division and the college degree, so 0.08, divided by the probability of the special units division, which is 0.2. If you put that in your calculator, you should get 0.4, so 40%. So there's a 40% chance that if you're just looking at the firefighters in the special units division, there's a 40% chance that those firefighters have a college degree. So again, you're taking your sample space down to just the special units division firefighters, not everybody. And the last one, at least on the front, says the coach of the Striker soccer team has determined that 50% of the players on the team were also on the team last year. Okay. The coach also knows that 30% of the players on the team were on the team last year and attended soccer camp during the summer. What is the probability that a striker who was on the team last year attended soccer camp during the summer? So again, they're describing what's the probability of the striker who was on the team last year. That's describing the striker attended soccer camp during the summer. So they're looking for the probability that you went to soccer camp knowing you were on the team last year. That's what they're looking for. Okay. Now this will help build our probabilities. If you think about your formula, the two things we need are the probability of soccer camp and last year and the probability of last year, because remember, this is your denominator because it's your sample space. So we have two numbers here. The 50% is describing the number of players that were on the team last year, so 0.50 here. And the 30% is the numbers that were on the team last year and attended soccer camp, so 0.30. So the probability we're looking for, the probability that a striker attended soccer camp knowing that they were on the team last year, is 0.30 divided by 0.50. So when you do that, you end up with 0.60, which is 60%. A couple things to remember when you're doing these problems, you guys, because you're just doing one division, An easy way to check your work is to remember that probability can never be over 100%. And if you flipped these, did 0.2 divided by 0.16 or 0.2 divided by 0.08, or for the last one, if you did 0.5, you would get probabilities over 100%, and that should be triggering you that something is wrong. Okay. So now on the back, we're just going back to review the conditionals from yesterday. So it might be a good idea for you if you want to see if you have a good handle on what we did yesterday on the first day of conditional. You might want to pause the video right now and work through number 4 and work through number 5, and then come back and compare your answers to how I do it in the video. Okay. Okay, so for number 4, it says you're rolling a pair of number cubes, so I would be looking at my dice sheet. What is the probability that the sum is 7 if, so if is conditional, the numbers are different? So the probability that the sum is 7 given that, or if the numbers are different. So remember, this is my new sample space right here. So I'm going to go to my card sheet and I'm going to say, okay, how many of these options have numbers that are different? Well, if you look, I would actually do the opposite. We know we have 6 that the numbers are not different, because that's when you get doubles. So we know we have 36 total. So my new sample space is going to be out of 30, because that's the 30 options on your card sheet that have different numbers. Out of those 30, we want to know how many have a sum of 7. So remember, we don't want this one, we don't want this one. These are all the ones that the numbers are the same. So what's left is my sample space, the 30 that have different numbers. So how many of those have a sum of 7? Here's 1, 2, 3, 4, 5, 6. Yep, that's it. Okay, so we're looking at 6 out of 30, which is 1/5, or 20%. So you have a 20% chance that the probability, or I'm sorry, you have a 20% probability that the sum is 7 if the numbers are different. Now, the next question just switches that. So now it's saying, when is the probability that the numbers are different if the sum is 7? So the probability that your numbers are different if your sum is 7. So now this becomes your sample space. So I'm just going to go back to the same thing I just had, because that means my sample space, I already did the work for that. My sample space is anything that has a sum of 7. So since I already did the work for that, that's these 6 options. Okay, so right off the bat, we know this is a different problem, because now my sample space is only out of 6. We want to know, out of those 6, how many have different numbers? Well, 1 and 6 are different. 2 and 5 are different. 3 and 4 are different numbers. 4 and 3 are different numbers. 5 and 2, and 6 and 1. So in this case, all 6 of the items in my sample space have numbers that are different. So I have a 100% chance of that happening. So what that's saying is, there's no way I can get a sum of 7 if my numbers aren't different. Okay. All right. So now, for this one, we have Liliana, who tossed a coin 3 times. Okay, so you guys, I'll throw in an extra page here, but that's coming from, well, let's look at this. It's doing heads and tails. Okay, good. Sometimes it does even and odd. So heads, tails, just kidding, we're flipping coins. Pretend I didn't say that. Heads, tails, heads, tails, heads, tails, right? This is old news. We've seen this before. But by doing this, this creates our sample space. So my sample space here that I'm going to be working with is going to be these 8 options. Sorry, give me 1 minute to write them all out. It makes it a lot easier. Maybe not for you, but this is the way my brain operates. Okay, so these are your 8 options. So, part A says, what's the probability that she gets exactly 2 heads if the second toss is heads? Okay, so here's your if. And remember, I always say what's the probability that she gets exactly 2 heads if I know. It just helps me. The second toss is heads, so you're looking for the probability that we get exactly 2 heads. Exactly is important. If I know that toss number 2 is heads. So your sample space is now this. So I'm going to go up here and say, okay, how many have a second toss of heads? This one does, this one does, this one does, this one does. So those 4. So out of those 4 options, how many have exactly 2 heads? Not this one, it has 3. This one counts. This one counts. This one doesn't because it only has 1. So you're looking at 2 out of 4, or 1/2, or a 50% chance. For the second one, again, we just flipped it, okay, because it means that your sample space is changing, so really pay attention. What is the probability that the second toss is heads if I know she gets exactly 2 heads? So the probability that the second toss, so toss number 2 is heads, if I know she gets exactly 2 heads. Well, now my sample space has to change because now my sample space is right here. So, knowing that, I'm going to look at this differently and say, okay, that means my sample space is exactly 2 heads. So this one falls into that category, this one does, and that's it. So my sample space, there's only 3 options there. So out of those 3 options, which of those 3 is a second toss heads? This one is, this one's not, that one is. So you're looking at 2/3, I'll just clean that up a little bit, or 66.67% chance. Okay. All right, this last one is the PBT from your student resource book. So it says, Amy has 1 sibling. Okay, find the probability that Amy's sibling is a boy if given the following parameters. Okay, so we want to see if Amy's sibling is a boy. Parameter number 1 says nothing is known about the age of Amy or her sibling. So we're used to making trees that look like this, but we only have 2 siblings. So the first thing I'm going to do is think about, okay, well, what could possibly happen? I could have a boy or a girl on my first child. And then on my second child, I could have a boy or a girl, or a boy or a girl. So that means my sample space for both of these is boy, 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 girl, girl, boy, or girl, girl. So that's your sample space for both. Okay. Now, with that being said, we can go back and look at these questions. This says, we are looking for the probability that Amy's sibling is a boy if nothing is known about the age of Amy or her sibling. So, if you look here at your sample space, for parameter number 1, this is no longer a part of my sample space because Amy is a girl. That's what they're assuming by the name Amy. Amy is a girl, so that means boy, boy is no longer an option. So the probability that Amy's sibling is a boy, well, I have 3 options left in my sample space, and it says nothing is known about the age of Amy or her sibling. That means that the boy could come first or second. So here, we're just looking for the probability that Amy's sibling is a boy. So out of these 3 that are left, this could be possible and this could be possible because it's not saying that the boy is older or younger. The last one can't be possible because it wouldn't be a boy. So your probability there is 2 out of 3. Now, if we look, let's get rid of that, refresh it for the next one. Here it says, it is known that Amy is older than her sibling. Okay, so again, this isn't possible. Boy isn't possible. And now it says Amy is older than her sibling. So we have to assume that this whole part won't work of the tree because the girl has to be born first. So this guy's out too. So my sample space is down to 2. It was either Amy was born, then her brother, or Amy was born and then she had a sister, because we're just looking for the probability that the sibling is a boy. So in that case, with these 2 left over, the probability that it's a boy, well, that's 1 out of 2. And that's your answer. So it's about manipulating your sample space, what can, what can't happen, and so on and so forth. So your homework tonight is this, but it's also a review of other things. So not all of your homework tonight is going to be conditional probability. So your homework tonight is a worksheet that looks like this. So make sure you're looking for your keywords, the if, the ands, things like that. And all of your answers are on the back at the bottom. So make sure you check them as you go. Okay?